Hi everyone. So let us see what is jitter today. Jitter is basically the inconsistency in the latency of the system. So let's understand that with the help of an example. Let's say we have 5 requests R1, R2, R3, R4, R5, and each request is having a latency of, let's say, 10 milliseconds, 12 milliseconds, 15 milliseconds, 15 milliseconds, and 9 milliseconds. So the inconsistency in the latency, that is the difference between the latencies, is for the first two requests it's 2 milliseconds, the next two requests it's 3 milliseconds, the next two requests it's 0 milliseconds, and the last two requests it's 6 milliseconds. So this inconsistency, difference in the latency, is what is called as jitter. In an ideal system, right? In an ideal system that is perfectly stable, the jitter is always 0. Okay. Now, how do we calculate jitter of a system? The jitters can be calculated through either through you calculate it by an average mean or through a statistical method. Okay. So how do we calculate via an average mean method? Okay. So how do we calculate via an average mean? So if we see here, the jitter of the ith request is calculated as the difference between the latencies of last two requests. Okay, the present request and the last one request. Okay, and taking a modulus of that. Why modulus? Because jitters are always positive. Now if you take an average of all the request jitters, it's basically gives me an mean jitter. Okay, this is how my mean average mean jitters are calculated. Now if I talk about statistical method, right? So let's understand that with the help of a graph. So let's say we have a latency on the y-axis, and then we have a request on the x-axis. So let's say if there are 5 requests, R1, R2, R3, R4, and R5, and let's say latency is 5, 10, 15, and 20, and R1 is having, let's say, 5, R2 is having 10, R3 is again taking half, R3 is again having 5, R4 is 15, and R5 is 20. So let's say my average latency is 10, for example. So my jitter here for each request becomes the latency of that request subtracted by the mean latency. Okay, this mean latency is basically my average latency. So if my average latency is mu, then this average latency, difference between the latency with the average latency, is basically my jitter of that request. And if we take the average of the jitters for all such requests, it gives me the statistical jitter. Okay, so whether we are calculating the statistical jitter or whether we are calculating the average mean, an ideal system will always have the mean, always have jitter as 0. Now the main thing that we have to achieve is, the goal of the system should always be to reduce the jitterness in the system. So how can we do that? So we can do that with the help of an introduction of a jitter buffer. So what is a jitter buffer? It's basically a temporary memory that is used to minimize the perceived jitter in the system by a client. So how do we do that? Let's see with the help of an example. Let's say we have buffer here, buffer jitter, and let's say this is my client. Now client expects the request every 5 milliseconds. Okay, and we have, let's say, request coming in at different latency. So one request is coming at a latency of, let's say, 1 milliseconds. The second is coming again at the difference at 1 millisecond. The third one is coming after, let's say, 2 milliseconds. The fourth one is coming after let's say 10 milliseconds. Okay, so what this buffer can do is, it can store the request and it can keep emitting at the required time while storing the further request. So let's say even if the next request is delayed, the buffer still has requests responses stored that can be emitted at a constant rate of time. So the perceived jitter by the client will be effectively 0. Okay, now the buffer sizes of the system is basically determined by the tail latency. So we have talked about the tail latency, right? Tail latency basically is determined by the outlier latencies of the system. Okay, so since we are talking about the outlier latencies, if we are covering the outlier latencies, the latencies that are taking the most amount of time, and if those are covered in the buffer jitter, we should be always be good with the other requests. So that's why we always consider tail latencies while we are calculating the buffer size of the jitter. Now, where are these buffers used generally? So these are used in systems such as let's say live streaming, okay, or let's say in video conferencing. So in these systems, you do not want the system to buffer, or you do not want the system to basically have jitters, because the user experience will be bad, right? So you maintain a memory address wherein the next request bytes are stored, and there is a lag that is deliberately introduced so that the smoothness in the at the UI and is maintained, and the user experience is the best. Okay. Now, there are some use cases where we actually introduce jitter in the system, and we'll see that. So let's assume that you have 10 threads, okay, and all of them are trying to access the same shared resource, okay. So let's say it's a DB, so it's the same shared resource, and they're trying to, we spin up this all the threads at the same time, and they're trying to access the resource at the same time. So what happens is there is a heavy load that comes to the DB at the same time, okay, and there are race conditions that might arise also. To avoid all these scenarios, what we do is at the very start we introduce latency, okay, and these are like different latencies that are introduced at the start of each thread, and since the starting point of the each thread is different, the time when the resources are contended or accessed is different, and this jitter in the system helps in sequencing the access of the shared resources. So that's it for today. We'll see you in the next video. Thank you.